Good evening, Dr. Asha and also Mr. Dubai. Today we are going to explain about Experiment 3, Impact of Jet. Here are the group members, where the first one is me, my name is Ha Chin Ting, and also second one, Muhammad Afiq Ishraf bin Ishaq, third one, Noor Akila binti Ilyas, and the last one, Mani Wenten Analaki Anparasu. For this experiment, there is one concept which is impact of jet. When a jet of water flowing with a steady velocity strikes a solid surface, the water is deflected to flow along the surface. Let's consider a jet of water which impacts onto a target surface, causing the direction of the jet to be changed through, and the angle is shown in figure 3.1. Different geometry has different angles, so that from there we can get a formula which is force equals to density times with the volumetric flow rate times with velocity and 1 minus cos angle of the geometry.
For summary and objectives, we have two experiments, Experiment 3A and Experiment 3B. Experiment 3A is conducted to study the force produced by the water jet onto various solid targets with different geometries. For this experiment, we use two nozzle diameter, which is 5 mm and 8 mm, and two solid targets, which are 30 degree flat and 180 degree flat. The values were recorded at three different flow rates for both the shapes and for both the nozzle diameters. For experiment 3B, it was conducted to investigate the force produced by the water jet onto various solid targets with external force. For this experiment, we used two weights, which are 50 and 100 grams. Values were recorded for different solid targets, nozzle diameter, and as well as different weights. For the apparatus used for this experiment, we have the jet itself, the nozzle and the target, the different types of targets, the weights and targets, as well as the flow meter, the pump, and the sump tank. For this experiment, we are using the nozzle with the nozzle opening of 8 mm, and the shape of the target will be 30 degrees flat. So first, before the experiment, we have to measure the measurement, and then we have to on the pump. Then the flow rate will be set at around, for the first setting will be around 10 mm, 10 liter per minute, and after that we can see the impact of jet, and this will increase the length of this indicator, and then we measure the final measurement. So this will be for experiment A, and later on for experiment B we have to add in weights, and for this example I'm adding 100 grams, and again we have to measure the initial measurement, and later on we have to on the pump to our desired flow rate, which will be 10 liter per minute, and then we measure the final measurement of this indicator.
For result and discussion for experiment 3A, we can see from table 3.1, the higher the volumetric flow rate, the higher the force. And also if we compare with table 3.1 and 3.2, the difference in the degree of solid body target will result into higher force exerted by the nozzle. And also if we compare with table 3.1 and 3.3, the difference in the diameter nozzle will result into a higher force, which is the diameter nozzle is directly proportional to the solid body target, the degree of the solid body target, which resulting to the lower diameter nozzle and higher force exerted. As you can see in graph 3.1 shows the graph of force versus nozzle diameter for flat 180 degree solid body target, where the volumetric flow rate, the higher the volumetric flow rate, the higher the force exerted on the solid body target. But even though the same volumetric is exerted on the same body target, but the difference in the nozzle diameter, which is 5 mm and 8 mm, will resulting to a different amount of force. So the lower the diameter of the nozzle, the higher the force, the amount of force. And the same thing for the graph 3.2 for flat 30 degree solid body target, where the amount, even the amount of volumetric flow rate is the same, but the force for different diameter of nozzle will resulting to a different amount of force, where the lower the diameter, the higher the force.
There are two graphs for experiment 3B. The first one is force vs nozzle diameter for flat 30-degree solid body target. The second graph is the force vs nozzle diameter for flat 180-degree solid body target. There are 5 main things that were calculated for experiment 3B, which are velocity of the nozzles, impact of velocity, experimental force, theoretical force, and finally net force. So, for the conclusion, as the flow rate is adjusted to an increasing value, the higher distance between the nozzles and the interchangeable target. When the flow rate is higher, it creates higher force. Therefore, change in height becomes higher as well. As the weight increases, greater force is needed to counteract with the weight. The shape of the geometry also affects the velocity of nozzles and impact velocity followed by the net force. These are our references. So our presentation has come to the end. Thank you.